May 14, 1940. Dawn breaks cold and colorless over the Meuse River Valley near Sedan, where the morning fog clings to the water like a burial shroud. The air trembles with the distant rumble of engines. Panzer divisions grinding forward through the Ardennes, their tracks chewing through mud and forest floor with mechanical certainty. In the command half-track of the 1st Panzer Division, Oberstleutnant Hermann Bulk leans over a map spread across the vehicle's metal hood, his breath forming small clouds in the spring chill. Around him, German engineers and tank commanders share cigarettes and quiet confidence. They have just accomplished what the French High Command declared impossible. They have brought an armored force through terrain deemed impassable. And now the road to Paris lies open like a wound. In these men's eyes burns the light of vindication. For 22 years, they have lived with the humiliation of Versailles, with the memory of hunger blockades and the bitterness of a peace that felt more like prolonged punishment. They have rebuilt their military from the ashes of the treaty's restrictions, turning secrecy into innovation, transforming limitation into tactical brilliance. Their tanks, though fewer in number than those fielded by France and Britain combined, represent the cutting edge of modern warfare. Machines designed not for static defense, but for swift, coordinated breakthrough. The Panzer III and Panzer IV models, while lighter than their French counterparts, embody a philosophy of war that their enemies have failed to grasp. Speed and coordination matter more than armor plate and gun caliber. And in this moment, as the French Ninth Army begins to crumble before them, these German engineers and officers carry with them a conviction that borders on certainty. They have mastered the science of modern war. Their training is superior. Their tactics are revolutionary. Their industrial base, rebuilt through the intense focus of rearmament under National Socialism, produces machines of elegant efficiency. They have studied the Great War's lessons with the dedication of students who dare not fail the same examination twice. They know the value of combined arms, of radio coordination, of air-ground integration. They have, in their estimation, perfected warfare itself. But there's something else in their confidence, something that goes beyond tactical doctrine and mechanical engineering. In the officers' clubs in Berlin, in the technical journals published by the Reich Ministry of Armaments, in the lecture halls where young engineers learn their trade, a particular narrative has taken root, a story about German superiority not just in military matters, but in the very character of production itself. American manufacturing, they have been told, is a crude affair, mass production without soul, quantity without quality. The assembly of cheap goods by workers who lack the deep craftsmanship traditions of European artisans. The Americans, these engineers believe, can produce automobiles and radios for their soft civilian population. But war is a different matter entirely. War requires precision. War requires engineering excellence. War requires the kind of technical sophistication that only German training can provide. This belief is not entirely without foundation. Throughout the 1930s, German engineering has been justly celebrated. The autobahns that ribbon across the Reich represent marvels of civil engineering. The ocean liners constructed in Hamburg shipyards combine luxury with technical innovation. Firms like Zeiss produce optical instruments of unmatched precision. Mercedes-Benz and Auto Union racing cars dominate Grand Prix circuits with engines that push the boundaries of mechanical possibility. Even foreign observers acknowledge German technical prowess. When American engineers visit German factories in the late 1930s under various exchange programs, they return with reports that mingle admiration with unease. So when these men in the half-track near Sedan discuss the war's future course, when they calculate how long it will take to finish with France and turn their attention to Britain, they do so with the confidence of craftsmen who trust their tools. Some among them have read the intelligence reports about American industrial capacity, the numbers of American steel production, the output of American automotive plants, the theoretical ability of American factories to convert from civilian to military production. They have seen these numbers and they have dismissed them. Numbers, after all, do not tell the whole story. The Americans have factories. Yes, but do they have the engineering culture? Do they have the precision mindset? Can a nation of jazz musicians and Hollywood actors truly understand the demands of military production? These questions contain their own answers, or so it seems in May of 1940. As the Panzers roll west and the French army disintegrates before them, as the British Expeditionary Force retreats toward the Channel coast and the Netherlands surrenders, the German assessment of their own capabilities seems confirmed by events. In just 6 weeks, they will have conquered what the Kaiser's armies could not take in 4 years. The fall of France will stand as a monument to German military excellence, and in the wake of that victory, the conviction will harden. Germany has achieved a level of tactical and technical sophistication that the decadent democracies cannot match. But warfare is not a single battle, and industrial might is not measured in the span of weeks. What these engineers cannot yet see, what they cannot imagine as they lean over their maps in that spring dawn, is the arithmetic of a different kind of war. They cannot envision the scale of production that will soon be unleashed across the Atlantic. They have calculated based on what they know, on what their experience tells them is possible, on what fits within their understanding of how manufacturing works. They have measured American potential against German standards and found it wanting. This is their certainty. This is their conviction. This is their blindness. The mockery begins quietly in technical journals and military briefings, long before the full weight of American production makes itself felt on the battlefield. In 1941, when Lend-Lease begins delivering American equipment to Britain and the Soviet Union, German intelligence officers compile reports on the quality of this material. The assessments are filed with barely concealed disdain. American tanks are described as inadequately armored, their riveted construction inferior to German welding techniques. The M3 Lee medium tank, with its sponsor-mounted 75mm gun, is analyzed and dismissed as a design that violates basic principles of armored warfare. American aircraft are judged to be sturdy enough but lacking in performance compared to the Messerschmitt Bf-109 and Focke-Wulf FW-190. Even the famous P-51 Mustang, which will later dominate the skies over Europe, is initially assessed as merely adequate. These evaluations contain elements of truth. Early American tank designs do suffer from significant flaws. The M3 Lee is indeed an awkward compromise, a stopgap solution designed to get a 75mm gun into production quickly. American armor doctrine lags behind German innovations. American tanks in 1941 and 1942 are, in many respects, inferior to their German counterparts in frontal combat. German engineers, examining captured American equipment or studying photographs from the Eastern Front where Lend-Lease Shermans first see combat, find confirmation for their preconceptions. American mass production, they conclude, sacrifices quality for quantity. The Americans can build many tanks, but German Tigers and Panthers are worth 5 or 10 Shermans in combat. What these assessments miss is the nature of industrial warfare itself. They focus on individual weapon characteristics, armor thickness, gun penetration, top speed, while failing to grasp the strategic implications of production volume. They evaluate American equipment as if each tank, each aircraft, each truck exists in isolation, rather than as part of an integrated system of logistics and replacement. They think like craftsmen judging the quality of individual pieces, not like strategists measuring the weight of industrial economies. In the officers' messes and technical bureaus, the jokes begin. American tanks are called Tommy Cookers by the Germans who faced them in North Africa, a nickname that acknowledges both their tendency to burn when hit and the perceived softness of the soldiers who crew them. German Panzer commanders share stories of knocking out multiple Shermans in a single engagement. The accounts are accurate enough. A well-positioned Tiger tank can indeed devastate a Sherman platoon at ranges where the American guns cannot effectively reply. But these anecdotes obscure a larger mathematical reality. For every Tiger tank that Germany produces with months of skilled labor and precious resources, America produces a dozen Shermans. For every irreplaceable German tank ace, America trains hundreds of adequate crews. For every ton of German steel allocated to armor production, America produces 5 tons and has transport capacity to deliver it anywhere in the world. The German engineers who mock American production have grown up in a culture that values mastery, that prizes the skilled craftsman's ability to create something of lasting quality. It is a worldview rooted in medieval guild traditions, in the pride of work done right, in the satisfaction of excellence achieved through disciplined training. These are not foolish men. They are, in their way, the inheritors of a genuine tradition of technical achievement. But their very excellence has blinded them to a different kind of power, the power of abundance, of overwhelming material superiority, of industrial systems so vast that individual quality becomes secondary to collective output. In 1942, as the Wehrmacht pushes deep into the Soviet Union and Rommel's Afrika Korps battles for Egypt, German production reaches what its engineers consider impressive heights. Tank production increases. Aircraft manufacturing accelerates. The Reich Ministry of Armaments, under the increasingly frantic leadership of Fritz Todt and later Albert Speer, implements rationalization measures to increase efficiency. German factories work longer hours. Slave labor from occupied territories is pressed into service. Every available resource is mobilized. And yet, even at its peak, German tank production in 1942 totals approximately 9,300 units for the entire year. This is considered a triumph, a vindication of German industrial organization. Speer will later claim credit for production miracles, for keeping the Reich's war machine running despite Allied bombing and resource shortages. The numbers are real. German production does increase significantly under his administration. But these numbers exist in a vacuum of awareness. The engineers and planners celebrate their achievements without fully grasping what is simultaneously happening across the Atlantic. In that same year, 1942, American tank production reaches 24,997 units. This is not a misprint. This is not a theoretical capacity. This is actual production. Nearly 25,000 tanks rolling off assembly lines in a single year, 3 years before American industrial mobilization reaches its full potential. And these tanks are merely one component of American output. In 1942, American factories produce 47,836 aircraft. American shipyards launch 746 major warships and over 5,500 merchant vessels. American plants manufacture 257,000 artillery pieces, 41 billion rounds of ammunition, and 87 million tons of steel. The entire American economy is transforming into what President Roosevelt has called the arsenal of democracy. And this transformation is occurring at a pace and scale that German planners have not imagined possible. The mockery continues nonetheless, because individual German soldiers and engineers experience the war through specific encounters, not through statistical abstracts. When a Tiger tank commanded by Michael Wittmann destroys multiple Shermans at Villers-Bocage in June 1944, the story spreads through the Wehrmacht as proof of German superiority. And indeed, in that specific engagement, German tactical excellence and superior tank design carry the day. But what the stories do not capture is the larger context. For every tank that Wittmann destroys, 5 more Shermans are already on ships crossing the Atlantic. For every German victory, the logistical noose tightens. The very concept of attrition, of wearing down an enemy through the relentless application of superior resources, remains alien to German military culture, which has always emphasized the decisive battle, the brilliant maneuver, the victory achieved through superior skill rather than superior numbers. The moment of reckoning comes not in a single dramatic revelation, but in the slow, grinding accumulation of evidence that can no longer be explained away. It comes in Normandy, in the summer of 1944, when German panzer divisions that have fought their way back from the Eastern Front encounter something they have not experienced before, an enemy that does not run out of equipment. June 6, 1944. The invasion beaches are secured. The initial German response has been delayed, confused by Hitler's insistence on personal control and by the success of Allied deception operations. But within days, elite German armored units moved toward the front, preparing to throw the invasion back into the sea, as they have thrown back every Allied landing in the past. The Panzer Division, considered one of the finest armored formations in the Wehrmacht, advances through the Norman countryside toward the beachhead. Its commanders are confident. They have beaten the Soviets. They have beaten the British. They know their business. And then they encounter something that defies their experience, an invasion force that seems to have no logistical limits. The sheer density of Allied equipment shocks even veteran German officers. The sky is never clear of Allied aircraft. The roads behind the front lines are choked with American vehicles, not just tanks and guns, but trucks, thousands upon thousands of trucks, forming a mechanical river that never stops flowing. Where German units must carefully husband their fuel and ammunition, their American counterparts seem to shoot without counting, to move without worrying about supply. Every destroyed American tank is replaced within days. Every casualty is filled by fresh troops equipped with new weapons. Oberst Fritz Bayerlein, commanding Panzer, watches his division, trained with meticulous care, equipped with the finest tanks Germany can produce. Ground down not in dramatic battles, but in continuous, wearing combat against an enemy that simply has more of everything. His division's Tiger and Panther tanks can destroy any Allied tank they encounter, but the Tigers break down frequently, and there are no replacement parts. The Panthers burn through engine transmissions, and there are no replacements. Meanwhile, every burned-out Sherman he sees one day is replaced by two more the next. By the end of June, Bayerlein reports that his division has been reduced to a shell of its former strength, not by decisive American tactical superiority, but by attrition. The Americans do not fight with particular brilliance, he notes. They fight with abundance. They are, in his words, fighting with money, which in the calculus of total war means they are fighting with the product of an industrial base so vast that it has turned warfare itself into a problem of arithmetic. Other German commanders report similar experiences. The 12th SS Panzer Division, made up of fanatical young soldiers raised entirely under National Socialism, fights with desperate courage and achieves local tactical victories. But their after-action reports begin to show a subtle shift in tone. The confident dismissal of American capabilities gives way to reports that focus on material disparity. A company commander describes destroying 6 American tanks in an engagement, then having to withdraw because ammunition is low and no resupply is available. Another report describes a successful ambush of an American column, followed by a hasty retreat as Allied fighter-bombers arrive within minutes, called in by radio networks that function with a reliability German forces cannot match. The engineers, too, begin to understand. German technical officers who examine captured American equipment in Normandy make discoveries that challenge their assumptions. An American truck, a simple GMC CCKW, the famous deuce and a half, is disassembled and analyzed. The German engineers note that its construction is crude by their standards. The parts are not precisely machined. The tolerances are loose. The assembly is clearly designed for speed of production rather than longevity. And yet, the truck works reliably. More importantly, it is one of hundreds of thousands. The Americans have produced over 560,000 of these trucks during the war, and they are everywhere in the Normandy countryside, forming the logistical backbone of Allied operations. A German transmission specialist examines a captured Sherman tank and notes that its transmission is simpler than German designs, less elegant in its engineering. But it is also more reliable, easier to repair, and, most significantly, America has produced enough Shermans that the question of transmission longevity is almost irrelevant. If a Sherman's transmission fails, it is simply replaced with another tank. The careful German calculation of component lifespan, the meticulous engineering to ensure each part functions for a specified number of hours, becomes meaningless in the face of an enemy that treats tanks as consumable resources. The psychological impact of this realization cannot be overstated. These German engineers have spent their lives in a culture that values precision, that takes pride in doing things the right way, that judges work by the quality of its execution. They have mocked American mass production as a shallow substitute for real craftsmanship. And now they are confronted with the understanding that their values, however genuine, are strategically irrelevant. Precision loses to abundance. Quality cannot overcome quantity when the quantitative disparity reaches a certain threshold. The Americans, they realize, are not trying to build better tanks than German tanks. The Americans are trying to build more tanks than Germany can destroy, and in this objective, they are succeeding with a totality that makes individual equipment comparisons meaningless. There's a sound that defines the late summer of 1944 for the German soldiers fighting in France, a sound that embodies their dawning comprehension of the war's true nature. It is the sound of tank tracks on pavement, a low, grinding rumble that vibrates through the earth and can be heard for miles. In previous campaigns, this sound has meant German Panzers on the move, the mechanical heralds of Blitzkrieg. But in France after D-Day, the sound carries a different meaning. It means Americans are coming, and they never stop coming. A German infantry lieutenant, positioned in a defensive line south of Caen, describes the experience in a letter that Allied intelligence will later intercept. He writes of hearing the tracks at night, a distant grinding that grows steadily louder. He knows from this sound that an attack will come in the morning, that his position will be subjected to artillery fire from guns that shoot with what seems like criminal wastefulness. Then, assaulted by tanks that advance in numbers, his unit cannot hope to match. He has a single Panzerfaust anti-tank weapon for his entire platoon. His men have rifles and one machine gun with limited ammunition. Across from them, the Americans have tanks, tank destroyers, self-propelled artillery, armored personnel carriers, and supporting infantry equipped with automatic weapons and grenades in such profusion that captured Americans express surprise when told that German soldiers must conserve ammunition. The battle, when it comes, follows a script that has become grimly familiar. The lieutenant's position is hammered by artillery, not the precisely targeted fire of German doctrine, but a bombardment so overwhelming that it seems designed to simply erase the landscape. Then the tanks come, not in clever tactical formations, but in straightforward, grinding advances that accept losses because losses can be replaced. His men fire, destroy 2 American tanks with their single Panzerfaust and a captured American bazooka. The tanks keep coming. His position is overrun not through superior American tactics, but through the simple application of overwhelming force. He and the survivors retreat to another defensive line, knowing that the same process will repeat the next day and the day after, grinding his unit down to nothing through sheer attrition. In the decades after 1945, as historians and military analysts dissect the Second World War's lessons, the question of German industrial miscalculation becomes a subject of sustained examination. How did a nation of engineers, famous for technical prowess and rational planning, so completely misjudge the industrial balance? How did Germany's technical elite convince itself that quality could trump quantity when all historical precedent suggested otherwise? Part of the answer lies in ideology. National Socialism promoted a worldview that emphasized will over material factors, that celebrated Germanic superiority and dismissed other peoples as racially inferior. This ideology predisposed German planners to underestimate their enemies, including the Americans. If one begins with the assumption that democratic, racially mixed societies are inherently weak and decadent, it becomes easier to dismiss evidence of their industrial strength as somehow unreal or unsustainable. But ideology alone cannot explain the miscalculation. Many German engineers were not particularly ideological. They were professionals, trained in technical disciplines, accustomed to working with empirical data. They had access to intelligence about American production. They knew in abstract terms that American industrial capacity exceeded Germany's. The failure was not one of information, but of imagination, an inability to translate abstract statistics into concrete operational understanding. This failure of imagination stemmed partly from experience. German engineers in the 1930s had witnessed the transformation of German industry under rearmament. They had seen production increase dramatically. They had personally contributed to this increase through rationalization and improved manufacturing techniques. Their experience taught them that industrial output was constrained by factors like skilled labor availability, precision tooling, and technical expertise, all areas where Germany excelled. They had no experiential framework for understanding an industrial system that approached manufacturing differently, that sacrificed some precision for massive increases in volume, that trained workers for specific tasks rather than general competence, that standardized components to enable semi-skilled labor to produce complex goods. American mass production techniques, pioneered by Henry Ford and refined across American industry, represented a genuinely different industrial philosophy than the one that prevailed in Germany. German manufacturing emphasized the skilled craftsman capable of producing high-quality goods through long training. American manufacturing emphasized the assembly line where semi-skilled workers performed repetitive tasks, producing adequate goods in high volume. Neither approach was inherently superior for all purposes, but in the context of total war, the American model possessed overwhelming advantages. It could scale more rapidly. It could absorb less skilled labor, including women and minorities previously excluded from industrial work. It could achieve productivity levels that made individual product quality less critical. German engineers, steeped in their own manufacturing tradition, quite literally could not imagine how Americans achieved what they achieved. When shown American production figures, they assumed either that the figures were inflated propaganda or that the products must be of such low quality as to be militarily useless. Neither assumption proved correct, and by the time reality became undeniable, Germany's strategic position had deteriorated beyond recovery. There is a final irony in the story of German engineers and their mockery of American production, an irony that speaks to the complex legacy of the Second World War. In the war's aftermath, many of those same German engineers who had scorned American industrial methods went to work for American companies or for the American military. Their expertise, particularly in fields like rocketry and jet propulsion, was valued despite their having been on the losing side. They brought with them the technical sophistication that had characterized German engineering, and they contributed to American aerospace advances that led ultimately to the moon landings and modern aviation. But they also absorbed lessons from their American colleagues. German engineers working in the United States after the war learned to appreciate the virtues of the American industrial model, its flexibility, its scalability, its ability to produce adequate solutions quickly rather than perfect solutions slowly. They learned, in other words, that the crude American methods they had once mocked possessed their own form of sophistication, a sophistication of systems and integration rather than of individual components. This cross-pollination of engineering cultures, German precision meeting American pragmatism, contributed to the industrial and technological dominance that the United States achieved in the post-war era. The weapon systems and aircraft and space vehicles that emerged from this synthesis combined the best of both traditions: German technical sophistication in design, American industrial efficiency in production. But for the German engineers who lived through this transition, who went from mocking American production to working within American industrial systems, the experience carried a weight of recognition that younger colleagues could not fully share. They knew as abstract knowledge that they had been wrong about American capabilities. But more than that, they understood, in the intimate way that only personal defeat can teach, that their wrongness had not been merely factual, but categorical. They had failed to grasp not just American strength, but the nature of modern industrial war itself. Some, in their later years, spoke about this recognition. Werner von Braun, the rocket engineer who led Germany's V-2 program and later directed the American Saturn V program that sent men to the moon, occasionally reflected on the transition. He noted that German rocket engineers in World War II had focused on technical performance, building the most advanced rocket possible, while American engineers focused on reliability and producibility. The V-2 was, in purely technical terms, more sophisticated than early American rockets. But American rockets worked consistently, could be manufactured in quantity, and evolved rapidly because production techniques allowed for quick iteration. This, von Braun came to understand, was not a failure of German engineering skill, but a failure of German strategic vision. His team had been solving the wrong problem. They had been trying to build perfect weapons when they should have been trying to build adequate weapons in overwhelming numbers. By the time they understood this, the war was lost.